Hello, everybody, and welcome back to another forecast. Today, we're looking at our day 2 convective outlook and what our system is going to look like. I'll take a brief look at today's system. However, this is kind of a few splotchy wind and hail risks for the most part. Most likely just a few little possible MCSs that could form. The main risk, however, is this new day 2 enhanced risk with a 5% tornado region, 30% hatched wind, and 15% hatched hail. So that's what I want to look at in this forecast. I'll take a brief look again at this day 1, but for the most part, this is focusing on the day 2, which is going to be active for June 27th in the United States. So at the moment, really what's going on with our current day 1 stuff is a few specific wind risks that are possible today. Here is the south down here, right? There's a little squall line. I think this is ongoing. Or actually, this is the 15ZHRRR. This is kind of this morning, afternoon here. Basically, this is coincident with that, there's a little slight risk here. You can see it's ongoing as well, considering the way this is shaped. Right, kind of that little bow, that's because that's our ongoing storms. That's basically the risk for Arkansas. Again, if enough of these can really get together, that squall line could lead to some isolated wind damages. Same thing over here, I believe, is the hail risk over on this part over here near the mountains, right? It's wind and hail for the most part. This is our greatest hail risk. I'll take a sounding out there as well. You can see here on the H polar, just a few little updrafts that are somewhat strong, and if a few of them are able to really congeal kind of like this, they could end up with one unified stronger updraft, and with that you end up with better chances for hail. Take a rep mile sounding from right about the same time, just so we can kind of understand the environment. And after this, we'll look at the New York information as well. Here's our sounding. Again, we have some cape, and for the most part, it's not very strong, right? A little bit of low level shear, which could help to get a little bit of a supercellular structure, and that can help keep hail higher up in the atmosphere for longer. But there's not much there's not much cape to be have this system as a whole. You can see a bit of a maximum later on in the night, but if they can't keep themselves for long enough, then they're not going to really get good hail. Here's our most unstable cape. You can see those little bullseyes, but for the most part, cape isn't really reaching all that high. It is hitting about 3,000 in some spots, though. But moderate cape for the most part. That's why it kind of depends on storm mode, and that's the main reason there's a slight risks, because they don't really know if it's going to happen for sure. It's just a possibility. Lastly is our area up here in kind of the Pennsylvania vicinity. So the rat model again. You can see, once again, not too much cape to be had over here, right? So the wind damage risk, for the most part, it's very widespread. So the idea of this is going to be, like it shows here, lots of convection because of the uncapped atmosphere. Look at cape here. For the most part, it's somewhat uncapped for most of the day here. Surface low as well. Kind of probably more overnight convection kind of stuff. For the most part, we do have somewhat southerly winds here, and moisture is kind of affecting into the region, albeit not super strong, but we do have pretty widespread 60s dew points here. I think later on in the night, especially, is also that risk. Okay, you can see here, kind of this, a little bit of a disorganized line according to the HRRR model here. And we could see, again, basically the same thing we're seeing with our storms out here kind of in Colorado, is you have that chance of a few sustained updrafts able to really make it through and get that wind and hail damage. But otherwise, nothing too organized with any of this. Regarding our day 2 outlook, we have this huge enhanced risk here. Pretty widespread as well, and mostly for wind damage. So I'm going to look at that right now. First of all, let's look at the whole pattern of the atmosphere at the moment. We'd had the other days here. Here's like 500 millibars here. For the most part, we've had this high pressure ridge, and that's part of the reason why that day 1 here is much wider and bigger here for this like the East Coast area, because of the fact that that's where the main trough is at the moment. You can see the 500 millibar level that can help with forcing for that. But our main pattern at the moment is this huge high pressure ridge, kind of dominating around the Texas and New Mexico vicinity. However, as we go on into tomorrow, we're going to get a low pressure up here, kind of in British Columbia. I'm not 100% sure on the provinces of Canada. I know somewhere around here is British Columbia. We have southwest Canada here. That's where you end up getting that low pressure to begin, and that will make its way off to the east. Another important thing to keep in mind here is shortwave troughs. So if we zoom in, I can't zoom in there. You can kind of see these kinks in the flow. Not super strong flow in the 700 millibar level. You can kind of see here's our trough and a few little kinks in the flow. Not very easy to, not very well defined, but there are kind of there. So you can imagine there are possibilities of the shortwave working its way through and helping to force these storms up. Especially if we take our main sector here, Again, you can see these shortwaves. They all have right here is a pretty well defined one actually. Right, you can see the shortwave more on the wind barbs. You can see the change in direction right here. Pretty indicative of a shortwave trough. Surface cyclogenesis also looks to be pretty powerful. If we find a good sector for this, it's kind of a difficulty here. I'll just do the United States, but you have to imagine our area of interest. 500 millibar levels as this trough ejects right off into like past the Rockies here in like Montana. That's when we get our surface cyclogenesis. This is where it would be. You can see it definitely strengthens as the day goes on according to this rat model. And I believe the NAM model shows something very similar. Strong surface low here. Basically the same thing. I believe the NAM NST as well should show. I mean, they should. All models do seem to be agreeing quite a bit here. For the most part, seeing a lot of strong southerly flow infecting into this region. That's going to bring a lot much higher dew points, especially for the higher elevations. The rat model shows, I believe, mid 60s dew points for the most part. NAM is similar, a little more aggressive in that case. Both NAMs are a little more aggressive with dew points. But yeah, no, definitely strong surface cyclogenesis. We have a 996 millibar low pressure system here. And you can see pretty strong southerly flow. Some places reaching upwards of 20 knots here. You can see here in Kansas kind of a 20 knot region, but very strong flow getting up here. So we shouldn't have too much issue with moisture. And don't forget also corn sweat is when you have all those crops in the region. This is very much Great Plains look. So that should also help moisture with just the fact that moisture from the plants will evaporate. And that might be a large reason why you're seeing this huge increase in dew points. That could help these storms as well. I look at the HRRR now for reflectivity, just to understand the progression of this system. This is an annoying sector because you have kind of a very widespread region. I'll take the northern sector, be a little more easy to understand. So back here in Montana, on the higher elevations, you should get more convection starting early on. But there is this pretty large window here for convection, kind of in right along this huge line border. We have good cape as well. I forgot to mention that. Here's the cape, mean layer cape here. Storm motion should not be very strong with all of this until later on. But you can see we do have, pretty moderate cape for the most part, affecting into this region. Also very high up here. This is northeast Montana. All the way up here, we have at least 2,000 joules per kilogram of cape. We can zoom down here as well. All along this boundary, pretty good cape. Also kind of a dry line setup in some sense. I think it's more of a cold front. It's an annoying spot to get. Let me just get the whole United States. The sector is very annoying to work with. I'm not sure I can zoom in here. Let's see if I can. No, it's not going to work for us. I apologize for this. It's a little hard to get these sectors right. I'll just kind of be switching through between them. But you can see the states here. Here's South Dakota, Nebraska. I'll probably be switching up to this other one as well sometimes with North Dakota here, South Dakota here, Minnesota right here, and Montana in this vicinity. Whoops. Loader. It's kind of a weak dry line, but it kind of resembles it in some sense. Where you kind of have that pretty sharp difference that should be shown on the mass conversions, I would think. Kind of a mess, and I think really the main issue with this is that the environment ahead of the original storms that will form up here in Montana. And if you look here on the HRRR model, reflectivity is kind of an important thing to look at here because this area over here will likely be pretty moderately destabilized a little bit. Again, it's also higher elevation too, so there might be mass convergence zones there as well. That's going to be first early storms. They form out there in Montana, and then or Montana, Wyoming, and the outflow of these storms should be there. Let's check the rat model and see what the downdraft cape looks like. That's something I've been learning to use more often. Again, HRRR shows basically all these storms here will kind of merge together into more of a line segment here. You can see right there, 1Z, pretty well defined. These are definitely viewable storms for the most part. These storms here definitely look more elevated. Yeah, very much inverted V setup here. I might be a little bit, oops, I don't know what I did there. Might be a little bit off of the main moisture and stuff, but elevated storms definitely possible out there. I believe that's where the hail risk comes from, is those early storms. Yeah, these early storms forming in Montana, those are going to be elevated. Those are going to have that hail risk. Then as those converge, we'll end up getting that possible wind damage risk, especially You can see the hatch region here is very pretty much right where our line segment was in the HRRR, right here. Pretty well defined there. But you can see right here is also a good look. You have these kind of discrete cells here. A few right here, definitely a few right here as well. That could definitely be something, and you can see that for supercells and tornadoes. I don't know why this sounding is broken for me. I'm taking another sounding ahead of that line. You can see definitely a much better tornado atmosphere here. Very good shear in the lower 3 kilometers here. Lots of cape. 3 cape is not extremely high. That's more for systems where you want to know more marginal stuff. For the most part, we have almost 5,000 surface-based cape. Mean layer cape is 4,000. I mean, there's definitely this system will be uncapped for the most part. Storms will make it through and be surface-based as well, which is important to keep in mind. And they will be rotating going to this right here. So if storms can develop ahead of that line segment, that will definitely be dangerous to keep in mind of. I want to take one more sounding ahead of these cells here, right? Kind of the north moving cells, the ones that move from the south to the north. Those are always interesting to keep in mind as well. Something similar here as well. It's almost pretty supercellular, very nice critical angle as well. For the first full kilometer, you're having easterly winds that could really help rotate those cells. Not as much cape, but definitely that curvature in this photograph, as well as kind of some jetting off of wind higher up. But model data is definitely helping us out for that. I'll likely have another update later on as well. Here's our NAM model. It's still something a little similar, a little more discreet actually. We can look at the more southern sector here. They also show storms along here. Again, for the most part, it's very similar, but I think the southern mode is a little less extreme just because of the less higher elevations, which should help with that downdraft cape. Or should not help with that downdraft cape. Also, I forgot to mention that here's our 1,500 joules per kilogram of downdraft cape. So that means our outflow will be very strong. We do have a little bit of drier air, but for the most part, very well saturated. But again, decape is very important for line segments, and that should definitely help those storms. Here's our sounding from the north. That shouldn't be as wind damage. We could get a line of supercells going north as well. Lots of complexities with this system, and that's definitely why it's pretty broad. Closer to the day, might even see like a 10% or more upgrades as we get closer to the day. So it's just something to keep in mind and keep track of. But that's our main movement. One last thing actually I forgot to look at. Let's check our HREF model, or the viewer, excuse me. I like to look at updraft helicity, and what this does essentially is I can get probabilities of how much updraft helicity there'll be. That's rotation in updrafts. These are probabilities here. Oops, it's not showing up. There we go. Probabilities of updraft helicity. You have about 50% here in this Montana area. Then later on, especially in those northern storms, as I was saying, that could definitely pose a higher tornado risk, is because that's going to be more discreet. The southern storms look to be more of a wind damage risk. But you can see here, again, more possible supercells down here, 50% chance of updraft helicity in that area. For the most part, we do have pretty high updraft helicity chances, especially in this northern mode. So that's something to keep in mind. I think our greater tornado possibilities are going to be in this Montana, North Dakota, and like Canada region up there, that kind of that triple point area. But definitely a pretty widespread wind damage possibility. So I think the SPC, very obvious here. It shows pretty well what the risks would be. Other than that, that's about it. I think actually let's look at the other models for their reflectivity real quick. Let's check that out as well. They should be in agreement though. I'm pretty sure most models here are in agreement. Let's look right at 0Z. Here's our 0Z look at the HRRR. Lots of line segment looks, but here you can see a lot of those look at those possible embedded supercells. They're disagreeing a little bit. For the most part, though, you can tell it looks to be more wind damage because a lot of these do have little tiny squall lines embedded. So the storm mode should end up probably being a mixture of supercells and squall lines together. So pretty dangerous. That's definitely why they have this 5%, because there's likely going to be tornadoes. There's also very likely to be wind. So it's kind of a mixture, and you can't really pinpoint exactly where your highest tornado possibilities are. But again, I do want to say, highest probabilities are probably going to be in these northern storms out here near Montana, North Dakota. So that's the main tornado probabilities. Otherwise, I'll probably make a community post tomorrow just talking about this system. But out of time for this video, again, that community post will be on my update. So if you're interested in this system, make sure to keep watching the SPC information, and also other channels talk about this stuff as well. So thank you for watching. I will see you in the next video. Have a good one.